Welcome back, guys. This is the last video in the Data 1F shadow test series. Okay, and we've got a scattergraph question here, and this scattergraph shows the number of ice cream sold from an ice cream van each day against the temperature at midday that day. So, describe the correlation. Well, correlation just sort of implies relationship. It's not asking us to describe the relationship, just the correlation. And we can just say that it is a positive correlation because as we go to the right on this axis, as the temperature increases, so do the number of ice creams sold. So we've got this positive gradient. So positive correlation is the answer, but positive is acceptable on its own. One of the results is an outlier. Circle this data value on the graph. Well, outlier is exactly as it sounds. It lies outside the trend of the rest of the data. So that's obviously this one here. Predict the number of ice creams the van might sell when the temperature at midday is 20 degrees Celsius. Now there's 2 marks for this question, and the reason for that is that one of those marks is for drawing a line of best fit. So it hasn't told us to do it, but without it we would only get 1 mark, even if our prediction was sensible. So with a line of best fit, we do it by eye, make sure it's straight, try to get roughly the same number of points above and below the line, and try to make sure it represents the data as accurately as possible. So now we're going to go up from 20 degrees, and on my graph, yours might be slightly different, but on mine that predicts that about 26 ice creams will be sold on a day like that. Part D, explain why you should not use the line of best fit to estimate the number of ice creams sold when the temperature is 30 degrees. Well, when you're drawing your line of best fit, try not to go much further than your much further beyond your first bit of data and your last bit of data. So 30 degrees is a little bit further than that. And what we shouldn't do with scatter graphs is try to predict when we don't have the data to support it. It's called extrapolation, is the fancy name for it. What we've just done there is called interpolation. Inter meaning in between, extrapolation meaning extra on top. So we should try not to do that because simply we don't know that this correlation is going to continue. 26, 27 degrees is already pretty warm in this country. Who's to say that this curve wouldn't flatten out and do something else? Okay, so although 30 degrees is not that much further ahead, the go-to answer for these sorts of questions is that it's outside the range of data and therefore we shouldn't do it. Outside the range of given data, and that's fine. Okay, number 16. This is the record of weekly CD sales in a record shop. Draw a time series graph of this data. So a time series graph is just a line graph where the horizontal axis just represents time, that's all. So it's very easy to do. Week 1, 174 CDs were sold. So that would be 175. So it's just below that. Week 2, 183 were sold. So each every 2 little squares is 10, another 10. So 160, 170, 180. It's going to be about there. Week 3, 147. Week 4, 174. Week 5, 134. Week 6 is 156. Week 7 is 151. Week 8 is 138. Week 9 is 147. Week 10 is 129. Week 11 is 138. and week 12 is 160. Okay, and what you should do with a time series graph is just link it dot to dot basically with a ruler. It shows the ups and downs of the data. You've probably seen a time series graph if you've ever seen a graph of stocks and share prices, fuel prices, that sort of thing. Okay. Comment on the trend, a very simple answer just needed here. It's only a 1-mark question. The trend is that sales are decreasing. You should always try and refer to the context of the question in a data question. So sales of CDs are decreasing, but they will just accept decreasing as well. And that is the whole shadow test. Well done if you managed to get all this far.